Welcome back to my workshop. After the success of my latest short, the channel gained quite a few new subscribers. And I thought it would be cool to have subscriber counter always in sight. I looked through some DIY subscriber counters online, but none of them really caught my attention, so I decided to design my own. The build starts with printing all the necessary parts on a 3D printer. You can build one yourself as well. Links to the printable files and the GitHub repository with the source code are in the video description. The counter displays both the subscriber counts and total channel views. Unfortunately, with the current YouTube API, it's no longer possible to retrieve the exact subscriber count. Once a channel passes 1000 subscribers, the number only updates every 10 subscribers instead of every single one. It's a bit disappointing, but I still think it's a great gadget for any YouTube creator. The counter uses only a few basic components: a 6-digit 7-segment display, a panel mount USB-C connector, a buzzer, and a ESP32C3 Super Mini. I started the assembly by attaching the display to the 3D printed front panel using standard M3 screws. Next, I installed the ESP32. I decided the simplest solution was to just stick it in place using double-sided tape. Now let's move to wiring the display. Connect the display's VCC to 3.3 volts on the ESP. For now, I soldered a loose black wire to the GND connection, which we'll use later. Then connect DIO to pin 5 and CLK to pin 4. For these connections, I used solid core wire. It's more than enough for this application, since all the components draw very little current, so thin wires can handle them without any problems. Now let's assemble the frame that holds the front panel. I printed this part in black PLA to create a nice contrast with the white front panel. On the bottom of the frame I mounted a panel mount USB-C connector using two M2 screws. You can easily find these connectors on AliExpress. A pack of 10 costs just a few dollars, and you never know when they might come in handy. Right next to the USB-C connector, press the buzzer into place. Make sure you remember which pin is positive, as reversing the polarity may prevent it from working or potentially damage it. I used an active buzzer with a built-in oscillator. Once all the components are installed in the frame, the two parts can be assembled together. Now it's time to finish the remaining wiring. We still need to connect the buzzer and power from the USB-C connector. Let's start with the buzzer. Connect its positive pin to pin 6 on the ESP32. For now, I'm only soldering a black wire to ground. Next, take a third black wire and join all these black wires together. Then solder them to GND on the ESP32. This is the simplest way to create a common ground connection. The wiring is almost finished. All that's left is connecting power from the USB-C connector. First, solder a red wire to the 5V pin on the ESP32. When soldering these USB-C connectors, adding some solder to the pads first makes attaching the wires much easier. Now solder the red wire to the V pad and the black wire to the G pad. Once everything is soldered and checked, it's time for the first power up. Remember to flash the firmware to the ESP32 first. The initial uploads has to be done using USB cable, but later we'll be able to upload new firmware over the Wi-Fi. It's easiest to flash the ESP32 before sticking it to the enclosure, although there should still be enough room for a USB cable afterward. Just make sure to use fairly thick double-sided tape. I've used 2mm tape. The final step of this little project is simply gluing everything together. I decided to not use screws for the enclosure because I wanted to keep the whole project as simple as possible, so anyone can build one without having to buy a bunch of different screws in the different lengths. I used regular CA glue, which works really well with PLA, and used a NEMA 23 stepper motor as a way to hold everything together while the glue cures. Now it's time for the first power up and mounting the counter on the wall. I won't go through the entire configuration process in this video. You will find instructions on GitHub explaining how to set everything up for your own channel. And that's it for this project. Thanks for watching and I will see you in the next one.